Oil, one of the Earth's most important natural resources. Almost ranks up there with water, only I wouldn't try drinking it. But it's vitally important to the economy of the world, yet always damaging when released back to nature. Major accidents create major headlines and devastate our natural resources.
All these traffic checks on all these underground, evidently we get some oil, and we're going to be here for a while.
But it's not always the big spills that get and need attention. Every day, millions of gallons of oil products are pumped. And every day, thousands of gallons are spilled back into the environment because of poor equipment, poor training, and carelessness. Let's review some of the reasons why we, the Navy, have oil spills, and how with some insight we can avoid them. A bit more awareness, a little more care, and a little more common sense preventative maintenance could dramatically reduce the number of spills at Department of the Navy facilities. And wherever petroleum products are stored, they don't sit for long before they pass through some type of connection, whether performed by an operator or automatically. According to Department of the Navy statistics, every day and a half, someone causes an oil spill ashore, either directly through their actions or indirectly through their failure to act. We've got to find that person and stop them. Too bad it isn't that easy to eliminate spills. Here in the real world, overfills are a common type of spill. They're typically due to inattention on the part of the fuel operator, or to lack of information about the tank's size or current level. Today, let's go on delivery rounds with lead fuel operator Leon Vernon Stroud. His fuel farm buddies call him Elvis. And let's see how they do things at Naval Air Station Backwater, the base that Barack forgot. Hey Elvis, looking good.
Thank you. Thank you very much.
Say, you mind if I tag along a while?
No problem, stranger, but I got some work to do here if you don't mind. Let's see, I got a 2,000-gallon tank. Looks like it's about half full. That'd be 1,000 gallons. Got to fill it to 90%. That'd be 1,800 gallons. So I need to put 800 more in here. I need 800 more gallons inside this thing.
Elvis, that looks like a 1,000-gallon tank to me. And half full, if that eye of yours is properly calibrated, would be 500 gallons to full. And just 400 gallons to the fill limit. So 800 gallons would overfill at least by 300. Too bad Elvis never bothered to stencil the tank capacities on the side of his tanks. Guessing the size of single-wall tanks is hard enough. But it's worse when you can't even see the actual tank shell. Too often, the tank sizes listed in a facility's SPCC plan and other tank management records are just guesses.
Specs on that new Dodge tank.
They never measured their older single-wall tanks to calculate their true capacities. And they either never saw or they threw away the paperwork of newer diked or double-walled tanks.
Hey, you see that game on Sunday? Ball game?
Nice safety glasses, Elvis. Say, don't you think you ought to be paying attention to the tank? Things can happen fast when you're delivering fuel at 100 gallons per minute to a 1,000-gallon tank. The 100-gallon difference between 90% full and overflowing is only 60 seconds of inattention. And of course, that's assuming you aren't trying to put 2,000 gallons in a 1,000-gallon tank.
You know, I ought to replace that thing someday.
You ought to replace or report that thing today, Elvis. Gauges are a lot cheaper than cleaning up spills.
Oh. Wow, I guess that is a 1,000-gallon tank, stranger.
Give the man a cigar. He figured it out. Fortunately, the overfill would have gone into the space between the two walls of this double-walled tank. So the only damage would have been to the time clock, Elvis's time to drain the overfill. And of course, the trouble Elvis would have been in should his boss find out. Now let's move on to a tank Elvis can't overfill. This tank has positive connecting cam lock fittings, and it's equipped with a fill limiter. When the tank reaches the correct fill height, a float shuts off the valve in the fill inlet tube, much like a toilet.
Now, we don't keep a spare fill limiter around, so I'm going to demonstrate how it works with these two pieces of pipe. This pipe represents a fill inlet tube or fill inlet pipe, and the fuel will be going down in there to fill it up. This would be our pivoting float arm. This would have a float on the end of it out here, and as the fuel level rises, this would lift up to horizontal, which would actuate a valve that would close off the top of that fill inlet pipe. Now, if this is installed improperly, this thing could only come up part of the way and hit up against the side of the tank wall, something like that, and prevent it from going all the way to horizontal, and that wouldn't actuate the valve. That means that we wouldn't have any fill limiter. I'm in love, my tank's all filled up. Oh. Our automatic gauging system isn't working properly, but that doesn't matter because our fill limiter is automatic and it's going to keep us from overfilling anyhow. Not like that gauge ever worked properly anyway. Who needs it?
Elvis, if that gauge was defective from day one, it should have been replaced on day 2. And having a working gauge is important. Relying entirely on the fill limiter is a mistake. What if the fill limiter stuck? If you try hard enough, you can overfill a tank with a fill limiter. Just install it turned, so the float would hit on something inside, preventing it from moving upward properly. Or damage the float during installation, or fail to notice that it's getting sticky.
Yeah, you know, I ought to check that fill limiter someday.
The cam lock fitting on the tank end of the delivery hose isn't dry disconnect, which means there's no valve in that fitting to close off fuel flow when the connection's broken. Handled improperly, Elvis could spill fuel when he disconnects.
See, this hose still has some fuel left in it. So we got to walk this hose down, get all the remaining fuel out of it, let the pump drain it out. But before we do that, we got to break the connection and open up the valve. The reason for that is we got a system here that's kind of like holding your thumb on top of a straw when you pull it out of a drink. If you don't move your thumb off the top, then the fluid can't drain out. So what we do is disconnect it right here, pull it off there, and then we open up the valve with that. Now the air pressure can push down in here. We can walk it back, walk it on down. That should clean that out now. Then we shut our valve off again here. Then we can go do our non-dry disconnect side of the fitting.
Amazing. Elvis actually bothered to make sure the hose drained back into the tank, and the hose cap's gasket actually still sealed. Here's another common type of spill, the simple drip from a seal. A buck says Elvis doesn't pay any attention to that dripping fitting. Oops, I lose.
I'll fix that thing someday.
You ought to fix that thing today, Elvis. Drips add up. A single drop per minute will spill 40 gallons a year. That fitting is dripping about once every 5 seconds. 12 drops a minute. That's about 500 gallons a year. Elvis wouldn't think of emptying a 500-gallon tank onto the ground or even into secondary containment, but that's essentially what he's doing. Some people think the government gets its fuel for free. Right now we're paying about $1 a gallon, so that's hundreds of dollars a year flushed down the toilet for one little drop. But notice that Elvis has thoughtfully provided a drip pan where it'll evaporate, causing air pollution. And this tank does have secondary containment, but the hitch is that when it rains, that drip pan will immediately develop a sheen. It only takes one drop, and this pan is getting plenty of drops. So when the shallow pan overflows during a rain, there'll be a sheen on all the water in the secondary containment. That means that Elvis can't release it without causing a knowing violation of the Clean Water Act, or overseas, the final governing standards for that country. So Elvis better hope it never rains too long. Sometimes pipe leaks can be spotted by the discolored earth around them. Here's Elvis just in time to handle the situation in his own special way.
I think now will be a real good time to give you some pointers on keeping the truck up. Now you can see this leak here. See how wet that is around there? That indicates to me that that gasket's worn pretty good in there. That means that this thing could fail and leak during delivery, or even while we're driving on down the road. And you see these dog ears on here, see how loose they are? That means that even with the cap on, this could be leaking while we're driving on down the highway. You know, I ought to fix those things someday.
Now let's join Elvis as he refills the refueler truck at the loading rack. Basically, the refueler truck is just a rolling tank. The biggest problem is overfills and spills during transfer operations. Before Elvis does anything, he needs to bond the truck to the fuel system.
Well, first thing I'm going to do is disconnect this vent cap off the back of the truck, hook up my vapor hose, try and keep them nasty toxins out of the environment, because after all, I'm the king of the environment. Now this truck here is equipped with special air brakes. When this door opens, you can hear them air brakes go on. That prevents this truck from moving while it's being filled. I ought to get one of these on family van, keep them teenagers out of the mall. This truck also uses a Scully bottom loading system, and this here is a special Scully connector. Now this attaches to a receptacle here on the bottom of the truck. Now that Scully connector completes a circuit that runs through this truck's compartment, and on that circuit there's a high level sensor in there. So if the fuel level goes too high, it shuts off just like the switch on the light, and then the pump can't operate, you can't overfill the truck. Now the third item is we've got this here dead man switch. When you hold this down and everything else is right, you're going to get a green light over here. It means you're ready to fuel. Now you get a red light, could mean several different things are happening. Number one, you might have some dirt on the female end of that Scully connector. That could have a bad connection. You might have too high a fuel level in there. You could have a malfunctioning high level sensor. Or maybe your dead man switch is malfunctioning. Maybe it's shorted out or something. Now some places, they'll try and cheat the system by shorting out the Scully connector, or maybe even throwing this on bypass and completely defeating the rack Scully system. Of course, we don't do that around here. All right, now it's time to hook up our product hose to the truck. On the rack side here, we got a special spring-loaded pop-up valve inside there. Someone has to press up against that valve in order for it to deliver any fuel. So we come over here and hook it up to the other side of it. There's a pop-up valve on the truck side also. Hook the hose on there, clamp down them dog ears. Then we open up the valve on the hose with the manual switch, flip the valves there, grab our dead man switch, and now we're ready to go. This takes 1,000 gallons of fuel and she's just about empty, so I'll keep an eye on the meter and make sure we got the right amount in there. Keep a close eye on that meter.
That's a pleasant surprise, hearing Elvis admit that you need to watch the meter at all. Well, let's end this on a positive note. While I've poked fun at Elvis, he isn't stupid. His problem is complacency. He's too fond of cutting corners. He's crossed that fine line between knowing how things are done in the real world and being a bit lax. Contrary to popular opinion, years of experience will not magically prevent spills. Everyone should be a bit more aware, take a little more care, and do a little more PM. Let's go over what we've learned. Overfills. Operator error, mainly in attention, is one cause.
Wow, I guess that is a 1,000-gallon tank, stranger.
The best gauge in the world isn't worth a plug nickel if you don't watch it.
You know, I ought to replace that thing someday.
And even knowing the level, lack of information about the tank size can cause an overfill. Mark your tanks prominently after measuring your single walls and calculating their sizes, and after rechecking the papers on your double walls and diked tanks. Even experienced operators who think they know tank sizes can be really off. They may have calibrated their eyeballs on tanks that weren't the size they thought. And there are several ways you can lack information about tank level. You must have a properly working gauge. It has to be in a position and large enough so the operator doesn't need X-ray vision to read it. For tanks with fill limiters, the float needs to be installed so it doesn't hit the tank wall or other interior structure. And down a notch from overfills, we have simple spills, like when you break a cam lock connection and some spills out. You need to replace the gaskets and dog ears when they get damaged or worn. And down a notch from spills, we have drips. Drips add up. Now moving to the loading rack, let's go over a few pointers. Get a green light. If it isn't green, find out why. Watch the meter, and not just when the pump slows down. Well, that's it. All we're asking is that you be a bit more aware, take a little more care, and do a little more PM. You are the front line for saving tax dollars and for protecting our environment. To nature. Major accidents create major headlines and devastate our natural resources.
All these traffic sections, all these hard to ground, evidently leaking some oil, and we're going to be here for a while.
But it's not always the big spills that get and need attention. Every day, millions of gallons of oil products are pumped. And every day, Thousands of gallons are spilled back into the environment because of poor oil, one of the Earth's most important natural resources. Almost ranks up there with water, only I wouldn't try drinking it. But it's vitally important to the economy of the world, yet always damaging when released back. Poor equipment, poor training, and carelessness. Let's review some of the reasons why we, the Navy, have oil spills, and how with some insight we can avoid them. A bit more awareness, a little more care, and a little more common sense preventative maintenance could dramatically reduce the number of spills at Department of the Navy facilities. And wherever petroleum products are stored, they don't sit for long before they pass through some type of connection, whether performed by an operator or automatically. According to Department of the Navy statistics, every day and a half, someone causes an oil spill ashore, either directly through their actions or indirectly through their failure to act. We've got to find that person and stop them. Too bad it isn't that easy to eliminate spills. Here in the real world, overfills are a common type of spill. They're typically due to inattention on the part of the fuel operator, or to lack of information about the tank's size or current level. Today, let's go on delivery rounds with lead fuel operator Leon Vernon Stroud. His fuel farm buddies call him Elvis. And let's see how they do things at Naval Air Station Backwater, the base that Barack forgot. Hey Elvis, looking good.
Thank you. Thank you very much.
Say, you mind if I tag along a while?
No problem, stranger, but I got some work to do here if you don't mind. Let's see, I got a 2,000-gallon tank. Looks like it's about half full. That'd be a